everyone, welcome back to Ribbit's Bit. I'm your host, Ribbit, and today I'll be teaching you how to take an integral using a trig sub, but this trig sub has a cx rather than a 1x. Let's get started. So what is an integral exactly? Well, it's a mathematical solution to the question, what is the area under this curve? This has a ton of applications, but today we will be looking at this graph of 1 over the square root of 9 minus 4x squared. So here's our function right here. We want to find the integral of this. This is what the function looks like. It has vertical asymptotes at -3/2 and +3/2. It extends infinitely upwards and looks pretty intimidating. First off, let's brief these steps. Step 1. Sketch a triangle and fill it in. Step 2. Identify x using trig and then use that to find dx. 3. Identify theta using trig. 4. Identify the square root component using trig. 5. Plug in the discovered information and solve the indefinite integral in terms of theta. And, 6. Plug in theta to solve for the indefinite integral in terms of x. Step 1. We're just going to sketch a right triangle and label theta. From here, we need to figure out which components go where. If you've taken a regular trig sub before, use those same rules. If not, let me review it for you. These are found using trig, but you can use them as a rule of thumb when doing trig substitution. If your function involves subtraction, like 1 over the square root of 25 minus x squared, then you'll put the square root of 25 minus x squared on the bottom. If your function involves addition, like 1 over the square root of 4 plus x squared, you're going to put that square root of 4 plus x squared on the hypotenuse. The square root of the constant goes on the bottom here, and the hypotenuse here, and the square root of your x value always goes on the right side of the triangle, opposite from theta. I realize that our function here, 1 over the square root of 9 minus 4x squared, involves subtraction, so I'm going to use this template here. Alright, so I've put my square root of 9 minus 4x squared on the bottom of the triangle as directed. But something is strange about this equation. In previous examples, including the templates, the x squared just became a 1x. But this example is a little different. The x squared has a 4 in front of it. No worries, there is a very simple solution. When filling out the hypotenuse of the triangle, I will take the square root of the 9. Oh, I'm sorry. 3. On the side of the triangle, I've put 2x here because I've taken the square root of the x squared and the square root of the 4, giving me 2x. Step 2. Identify x using trig and then use that to find dx. Remember SOHCAHTOA here. Sine of theta equals opposite over hypotenuse. I plug in my information and I got sine of theta equals 2x over 3. From there, I can say that 2x equals 3 sine theta. Then from there, I can say that x equals 3/2 times sine theta. That's our x value. The derivative of that is just 3/2 times cosine theta because cosine is the derivative of sine. Excuse me, I have a frog in my throat. Step 3. Identify theta using trigonometry. In step 2, I use SOHCAHTOA to figure out that sine of theta equals 2x over 3. From there, I can then say that theta equals arcsine 2x over 3. Ta-da! Step 4. Identify the square root component using trig. According to SOHCAHTOA, cosine of theta equals adjacent over hypotenuse. After plugging in my information, I find that the cosine of theta equals the square root of 9 minus 4x squared over 3. Rearranging that gives me the square root of 9 minus 4x squared equals 3 cosine theta. Let's just review what I've found so far. I found that x equals 3/2 sine of theta, dx equals 3/2 cosine theta d theta, theta equals arcsine of 2x over 3, and that the square root of 9 minus 4x squared equals 3 cosine theta. Now I've turned all of my x components into theta components, and I could substitute that in for x to solve my integral in terms of theta. And that brings us to step 5. Plug in the discovered information and solve the indefinite integral in terms of theta. So right here I've got the integral of 1 dx over the square root of 9 minus 4x squared, which equals the integral of 3/2 cosine theta d theta over 3 cosine theta. I've figured this out by substituting in all of my theta terms instead of these x terms, because in this state it is not very solvable to me. So from then on, I can pull out the 3/2 and the 1/3 and make this 1/2 times the integral of cosine theta times d theta over the cosine of theta. That equals 1/2 times the integral of d theta, because these cosines cancel out. From then on, I know that once I integrate d theta, that becomes 1/2 times theta plus c. Like I said, we need to substitute this theta for an x. So I've got the integral of 1 dx over the square root of 9 minus 4x squared. I found out that that equals 1/2 theta plus c. But I also know that theta equals arcsine 2x over 3. So if I just plug that in to where theta is, I find that this integral equals 1/2 arcsine 2x over 3 plus c. Now let's just go over the steps one more time to see what we did. First, we drew this right triangle and we labeled it. We found x and its derivative, and we also found theta. We found this value, the square root value, and then we used all of that information to substitute in theta terms for x terms to find the integral of 1 dx over the square root of 9 minus 4x in terms of theta. From there, we just plugged in this value right here back into what we got here, and that gave us the integral of 1 dx over the square root of 9 minus 4x squared equals arcsine 2x over 3 over 2, or 1/2 arcsine 2x over 3, if that's easier for you, plus a constant. And that's it, that's your answer. Thanks for tuning in to this episode of Ribbit's Bit. Sorry that was so horribly long and painful. Sometimes that's just how calculus is. But remember, kids, knowledge is power, and everything around you is just math. Everything you know and love and understand is fundamentally just mathematics. Well, I'm gonna go have an existential crisis now.